Hi everyone, today I'm just going to take you through the DAFNI Visualization tool, which we'll shortly be bringing onto the platform for users to create visualizations with. The idea behind this tool is to give users an intuitive way to create visualizations without having to write any code, so that non-technical users can come on DAFNI, run a workflow, and also create a visualization which shows the outputs of their workflow. So I'll just take you through some of the details of the visualization tool in this demo. In the top left, we can see that we can select our input files, which we can then use to make the visualization. And we have a choice between CSV, top adjacent spatial kind of information, and a combination of the two. But if we stick with CSV for now and create quite a simple visualization, this is the Seattle weather data between 2012 and 2016. But we can also choose between different CSV files here. As we do that, the columns here will change. So here the columns have been pre-populated from our Seattle CSV data. If we just select this instead, for example, the columns then change and pre-populate from a different CSV file. But if we stick with Seattle weather data for now, we can then change our geometries on the left-hand side. So we can pick between a whole host of different plot types in this list. If we stick with line for now, we can then drag some of our columns across this aesthetics section to actually start generating the plot. So if we take the date column and the precipitation column, date on the x-axis, precipitation on the y-axis, we then get quite a nice plot of precipitation throughout the different months between 2012 and 2016. What you could then do is press Save Plot and fill in some metadata, and that would save a static plot of this, so in JPEG or PNG format, for example, which you could then share with other people on DAFNI. So without having to come to this visualization tool, they could see the outputs of your visualization effort, if you like. What you can also do is save a template, again, fill in a short piece of metadata. And what that essentially saves is this Vega Lite specification, which is just JSON. And that essentially allows you to recreate this visualization at a later time without having to go into the tool and to drag all the columns across. So in this example, that was quite easy. I just had to drag 2 columns across, but you can see how you could create more complex visualizations that you don't necessarily want to spend the time recreating every time. So you could then create a template, save that, and you could recreate a fresh instance of a tool with that template. And so you can imagine if you've got the Seattle weather data between 2017 and 2020, you could then create this exact same plot from that template without having to do all the work again. But just to give you another example of another geometry type, we can get rid of the line plot that we've just drawn, and we could go for a circle plot. Again, date on the x-axis, we go for temperature on the y, which is quite nice. And then we can color by precipitation, so you can get an idea of 3 different data points there in one go. So you can see how you can quite easily create quite complex plots, and hopefully it's intuitive for the regular user. What we can then do is plot a spatial type plot instead. So if we go over here and select top adjacent, we can see map of the UK. This is just the local authority districts in the UK. We could then plot this, which is a more granular picture of the road network in a certain area of the UK. I'm not quite sure where this is. But then we can see the features in the top adjacent itself, and we can drag those across to the color. So you can easily pick out here, this is probably a motorway because this is the speed, I think, in kilometers per hour of the different roads. So you can see how they're probably the motorway arms. And again, you can plot a whole host of different things on this GeoJSON plot from your features within your GeoJSON. But what's really cool is if you've got let's say a CSV with a load of metadata and then a GeoJSON with a load of polygon information, you can actually combine the two using the tool. So you can take the features of your CSV and plot them on top of your GeoJSON as long as they link together in some way. So here we've got some link travel time information about the roads that we were just plotting on. So if we get that GeoJSON back, and then we just have to pick a column to link them by. So there's a column in the CSV called Edge ID, and there's a feature in the GeoJSON called Edge ID as well. And what that'll do is it'll reproduce our road block from earlier, but now we have a whole host of other columns to choose from, and they come across from the CSV because we've linked them together in that way. So if we take, this CSV essentially shows the travel times at different times throughout the day, so you can see all these different times throughout the day. And if we go for midnight and color by midnight, you can see the different travel times on these different segments of road at midnight, which is really cool in combining those two bits of information. And as with the CSV plot, we could save this, we could save it as a template and reproduce later on from a similar set of data. So that's all I wanted to say about the visualization tool. Hopefully it's coming to DAFNI soon. Thank you.